Dear students, today we will talk about twisting couple on a cylinder. So we assume a cylinder whose length is suppose L and whose radius is R. So its radius is R, its length is L. Now let us turn the cylinder through certain angle. And when we do that, suppose here is a point A and after turning it reaches a point B. So suppose with the center of the base, it makes an angle theta. This is the angle theta. And let us assume that this distance OB is equal to OA is equal to x. So OB is equal to OA is equal to x, for example, right? So what is the measurement of this AB then? Obviously, we know that the length of the arc is equal to radius into angle. So we can say that AB is, what is radius? It is x. And what is angle? It is theta. Now let us see what angle does the lower face of the cylinder make with respect to the upper face. So that will be shown in this way. We'll have to join it this way and then join another line with this point. So all we do is that we join the points A and B to the center of the upper face of the cylinder to determine the angle through which the lower face has turned with respect to the upper face, and that angle is called phi, for example. So phi is called angle of shear, and you must be well versed in that. You must have learned about that in your class 11th or 12th. That angle of shear is the angle through which the lower face of a cylinder or a body turns with respect to the upper face once we have turned the body by using a force or a torque, right? So we can say that this phi into L is equal to AB again, because the length of this arc is again the radius. At this time the radius is L and the angle is phi. So this AB, length of this AB is also equal to L into phi. So we can equate these two, that x theta is equal to L phi. So I'm going to repeat these details. These are very important. So we imagine a cylinder of radius R and length L, and we choose any point on the base. Once we turn the cylinder through certain angle, the point A reaches point B and draws an angle theta with respect to the center of the base. Another angle is phi, which these 2 points draw with respect to the upper face of the cylinder. And this angle is called as angle of shear, right? And we can say that this length AB can be determined in 2 ways. Either it is this way, OA into theta, or it is L into phi, because the length of the arc is equal to the product of radius of the circle and the angle subtended at the center. So that way this AB is x theta and it is also equal to L phi. So we have equated these two. X theta is equal to L phi. From here we get phi is equal to x theta by L. Now we know that modulus of rigidity neta is equal to shear stress by shear strain. Remember, shear strain is another name of angle of shear. So shear stress by shear strain, that is phi, is equal to neta, or we can say that stress is equal to neta into phi. So stress is itself force per unit area, and neta, we can give the value of this phi. This phi is x theta by L. Now let us try to find the value of this area. We know that this cylinder can be assumed to be made up of a large number of inner concentric cylinders. So let us choose one whose radius is x and whose thickness is, suppose, x plus dx. So this distance is x and the outer part, that is the thickness, is dx. So once you visit the books, you are going to get a clear picture of this diagram. But here you have to understand it very roughly. Therefore, we can trace this area as 2 pi x, that is the circumference, into dx. That's it. 2 pi x into dx. We know this OA is x, this OB is x, and this is the radius of the inner cylinder, inner concentric cylinder, and its thickness is dx, right? So the area is 2 pi x dx. So this is neta x theta by L. Therefore, what is this force? Force is, this is 2 pi neta theta x square by L dx. So it is 2 pi neta theta x square by L dx. Now we are interested in torque, the turning effect of force, because we have turned the cylinder with respect to the upper face through an angle theta. So this torque is, small torque is, theta is Fx. Force into force arm. All of you know that, a very basic elementary thing that you have learned right from the school level. So torque is force into force arm. That is force into x. Here it is x. So what's that? So it is 2 pi n theta. Now it will be x cube. With this x, it will be x cube dx by L. So that is d torque. If we are interested in finding the total torque, that will be given by the integration. So we'll do that on next page. So that will be, let us rewrite this expression. It will be d tau is equal to 2 pi neta theta x cube dx by L. So once we do the integration to find the total torque, that will be this way. So it is 2 pi neta theta by L. They are all constants. They will come out. Integral x cube dx. And that will be 2 pi neta theta x4 by 4 by L, right? And suppose we have integrated it from 0 to r, because we know that x is a parameter along the radius of the cylinder. So we can choose to integrate it between limits 0 and r. In that case, it will be r4 by 4, right? So in all, we can write, it is, this 2 will get cancelled. It will be neta pi theta by 2L r4. This is the torque. But if we are interested in finding the couple or torque per unit twist, and what was one twist equal to? It was theta, because we had rotated the cylinder by an angle theta. So a unit twist is how much? Theta. So if we are interested in finding the torque per unit twist or the couple per unit twist, it is, we'll be dividing by theta, that is n pi by 2L r4. And that is the final expression for couple on a cylinder which is rotated through a small angle theta, and in which the lower face gets turned by an angle phi with respect to the upper face. And as simple as that. So you have to remember this formula to face the numerical problems. That's it.